Welcome to Daily Papers, the podcast where we break down the most interesting new research papers into bite-sized, easy-to-understand chunks.
Today, we're diving into the world of artificial intelligence and computer chip design, which might sound a bit dry, but I promise you, this paper has a headline that will grab your attention. Can an AI design a better computer chip than a human engineer?
That's a pretty bold claim. We're talking about the tiny, incredibly complex brains inside our phones, laptops, and everything else. For decades, designing these has been a purely human endeavor, requiring immense expertise.
Exactly. The paper we're looking at is called ChipSeek-R1, generating Human-Surpassing RTL with LLM via Hierarchical Reward-Driven Reinforcement Learning. It's from a team at the Chinese Academy of Sciences and other institutions.
Okay, that title is a mouthful. Let's start with the basics. What's an LLM and what is RTL?
An LLM is a large language model. Think of AIs like ChatGPT. They're amazing at understanding and generating text, and RTL stands for Register Transfer Level. The simplest way to think about it is that RTL code is the architectural blueprint for a computer chip. It's a special programming language that describes exactly how the hardware should be built and how it should function.
So the goal is to get an AI to write the blueprint for a computer chip just by giving it a description of what the chip is supposed to do. That sounds useful. What's the problem?
The problem is that just getting a working chip isn't enough. In chip design, engineers are obsessed with three things, which they call PPA: power, performance, and area.
Power, performance, area. Let me guess, you want the chip to use as little power as possible, have the highest performance, or speed, and take up the smallest physical area on the silicon wafer.
You got it. It's the holy trinity of chip design. The problem is current AIs are not very good at this. They can be trained on millions of examples of human-written code, and they can learn to write a blueprint that works. But the chip it describes might be a gas guzzler. It works, but it's slow, big, and burns way too much power.
So the AI can follow a recipe, but it has no sense of taste. It can't tell a good design from a bad one.
That's a perfect analogy. The AI doesn't understand the consequences of its design choices. It doesn't know that one way of writing the code might lead to a chip that's 10% more efficient. And that's the gap this paper, ChipSeek-R1, tries to solve.
So how do they give the AI a sense of taste?
They use a technique called reinforcement learning. Instead of just showing the AI good examples, they let it experiment. The AI tries to write a chip blueprint, and then it gets a score or a reward based on how well it did. If it does something good, it gets a treat. If it does something bad, no treat. Over time, it learns what works.
But what counts as a good design? This is where the PPA stuff comes in, right?
Precisely. And this is the most clever part of the paper. They created what they call a hierarchical reward system. The AI's code has to pass a series of levels, almost like a video game, before it can even get a score for PPA.
Okay, I'm listening. What are the levels?
Level 1 is just basic formatting. Did the AI present its answer correctly? Level 2 is a syntax check. Is the code grammatically correct? Will it even compile? It's like running a spell check. If it fails here, game over, try again.
Makes sense. What's level 3?
Functionality. Does the chip blueprint actually do what it was asked to do? They test this using simulators, the same kind of software human engineers use. If it passes, it moves to level 4. Can this design actually be manufactured? Can it be turned into a physical thing? And only if it passes all of those levels does it get to the final boss, the PPA score. The system then measures the power, performance, and area of the proposed design. The better the PPA, the higher the reward the AI gets.
So it's a complete feedback loop. The AI tries something, its design is run through the very same tools and tests that a human engineer would use, and it gets a real, concrete score that tells it how well it did. It's not just guessing, it's learning from hard data.
Exactly. It's learning the art of trade-offs, the very thing that makes a great chip designer. And the results are, well, pretty staggering.
Don't leave us hanging. Did it work? Did the AI beat the humans?
In many cases, yes. They tested their AI, ChipSeek-R1, on a benchmark set of 50 different chip design problems. For 27 of those designs, the AI produced a blueprint that was better on those PPA metrics than the original human-written code it was being compared against.
27 out of 50. That's more than half. How is that possible?
The paper gives a great example with a component called a barrel shifter. The human way to design this involves building it out of smaller, well-known digital blocks. But the AI, through trial and error, learned that it was better to just describe the high-level behavior of the shifter and let the modern, sophisticated optimization tools figure out the best way to build it. It found a more elegant, more efficient solution because it wasn't constrained by the way things are usually done.
It's thinking outside the box because it never knew there was a box to begin with.
That's a great way to put it. It's not just mimicking human engineers anymore. By giving it the right goals, make it fast, small, and efficient, and the right tools to measure its own success, the AI is starting to discover novel design strategies on its own.
So this could be a huge deal for the future of technology. If we can automate the design of better, more efficient chips, that could accelerate everything.
That's the potential. This paper shows a path toward a future where AI and human engineers collaborate, with the AI exploring thousands of design possibilities to find solutions that are not just functional, but genuinely superior. It's a big step toward automating one of the most complex creative fields in engineering.
So by teaching an AI to care about the same things human experts do, power, performance, and area, we can get it to not just match them, but sometimes to beat them. A fascinating look at the future of design.
That's all for today's episode of Daily Papers. Join us next time for another look at the world of research.